to write measurements while respecting the number of significant digits. So I have an example here where we use a tool to measure the diameter of a piece of metal here. And we measure two different pieces. The first one we measure 14 millimeters, and the second one we measure 10 millimeters. But if we use the rule now for significant digits, well, this one has 2 sig figs, and this one only has 1 sig fig, because we saw the rule where zeros to the right of a non-decimal number are not significant. But we used exactly the same tool as we did for this one. So what does that mean? It means that we cannot write 10 millimeters. Otherwise, the person reading this will think that our measurement tool only has 1 sig fig of precision. So what are we going to do? Well, we can use centimeter. Centimeters will give you 1.0 centimeter. And now in centimeter, we have 2 sig figs, because zeros to the right is case number 2, where it tells us that zeros to the right of the decimal point are significant. We can also use the scientific notation. So we can also write 1.0 multiplied by 10 millimeters. If you want to use millimeters, now we're going to have 1, 2 significant figures. That 10 here is only to get the right number, but we will use this to signify that there is 2 significant figures. Let me show you other examples. So I'm going to erase all of that. Show you a few examples right here. I'm going to have to click here. A few examples where we have 3.20 multiplied by 10 to the power of 2. Well, the 10 to the power of something is not inside the measurement. It's only to give an idea how big the number is. So the only significant digits are going to be 3, 2, and that 0 is to the right of a decimal number, so it counts as well. So it's going to be 3 significant digits. This one is going to be 4. That 0 counts because there's a decimal point and they're to the right. So it's going to be also 3 sig figs. And finally, that 5.4 is going to be 2 sig figs. Thanks for watching. See you in the next video.